Everything you think you know about human evolution is profoundly mistaken. We are taught that humanity is a species in constant, slow, upward biological ascent, perpetually adapting, a slow climb from primitive forms to our complex modern state, through countless generations of trial and error, subtle shifts, and relentless environmental pressures. But the evidence suggests it didn't evolve in this continuous, meandering way at all. It simply stopped asterisk. The modern human form, our intricate cognitive architecture, our very biological essence, didn't appear through endless refinement. Instead, at a specific juncture, humanity's evolution didn't just slow down. It simply froze asterisk. It is as if an intricate genetic blueprint was delivered, meticulously assembled, then definitively stamped final, not a process of ongoing discovery and modification. Something truly unsettling awaits. For centuries, the narrative of human evolution has been a comfortable story of endless progress. From the earliest hominins scrambling through ancient landscapes to the emergence of asterisk Homo sapiens, each step marked by subtle changes, new adaptations, a slow, inevitable march towards greater complexity. We picture a continuous biological current, forever shaping and refining us. And indeed, the fossil record for millions of years seems to support this. Bones shift, brains grow, tools become more sophisticated, all pointing to a relentless, albeit gradual, biological drive. This is the accepted scientific consensus, a foundational pillar of our understanding of ourselves. But there is a problem with this comforting narrative. When we examine the archaeological and genetic record of the last tens of thousands of years, we find something profoundly strange. We find a biological stasis. The relentless current seems to have gone still. The changes that once defined our very existence, the morphological shifts, the rapid brain development that characterized our journey from ape to human, seem to have largely ceased. Instead of continued evolution, we observe a sustained, almost unnatural biological pause. This is the central enigma that compels us to look deeper, to question the very nature of our species. Consider the human skeletal structure. For millions of years, our ancestors' bones told a dynamic story of adaptation. Changes in pelvic structure for bipedalism, modifications in jaw and teeth as diets shifted, the lengthening of limbs, the refinement of hands. Every new fossil discovery presented a slightly different iteration, a step along a winding path. Then, roughly 50,000 to 70,000 years ago, something shifts. The skeletal and cranial features of what we recognize as anatomically modern humans, asterisk Homo sapiens, appear to reach a remarkably consistent form. We see robust individuals, yes, but the fundamental blueprint seems set. The mainstream explanation for this apparent anatomical stability often posits that Homo sapiens simply reached an optimal configuration. Our bipedal stance, our brain size, our dexterity, all achieved a peak efficiency that served us incredibly well. Minor variations, of course, occurred due to dietary changes, regional adaptations, and population movements, but the core design remained steadfast. The argument is that the need for significant structural overhaul lessened as cultural and technological adaptations began to take precedence. Why evolve stronger bones when you can build stronger shelters? Why grow sharper teeth when you can fashion more effective tools? But there's a quiet disquiet in this explanation. While minor shifts are undeniably present, the fundamental structure and proportion of the human body have shown an astonishing lack of major evolutionary drive since the Upper Paleolithic. Where are the new bone structures, the altered musculature, the significant changes in brain casing that marked our distant ancestors? If evolution is an ongoing, adaptive process, why this profound cessation of significant anatomical change? It's almost too stable, too perfectly preserved, suggesting not merely an optimal form reached, but perhaps a blueprint that became strangely impervious to further radical alteration. Some researchers, looking at this profound anatomical consistency across vast geographical and temporal spans, wonder if an optimal physical form wasn't just asterisk reached asterisk, but somehow asterisk locked into place. Could there be a biological, hard limit on certain growth patterns, an inherent genetic boundary that once crossed restricted further radical shifts? What if, having achieved a certain structural integrity and functional balance, the very genetic mechanisms that drove those changes became quiescent, or even deactivated? The alternative theories whisper of a kind of biological finality. Was a template set, not just for the brain, but for the entire physical chassis, halting its dramatic transformation? Has our physical form been strangely perfected, and then frozen in time? Or are we missing a crucial chapter in our biological story, one where the dynamic engine of change was mysteriously stilled? Perhaps even more perplexing than the anatomical stasis is the profound puzzle of our cognitive development. Around 50,000 to 70,000 years ago, humanity experienced what is widely referred to as the Great Leap Forward, or the cognitive revolution. This period saw an unprecedented explosion of complex behaviors, intricate cave art, sophisticated tools, symbolic thought, ritual burials, and the unambiguous emergence of spoken language. It was a dramatic, almost sudden, blossoming of what we understand as modern human intelligence. Our ancestors, who had been making relatively simple tools for millennia, suddenly began to innovate, create, and communicate with astonishing sophistication. The mainstream view explains this as the final major step in brain evolution, the culmination of millions of years of gradual increase in cognitive capacity. This leap, according to conventional understanding, set the stage for all subsequent cultural and technological growth, effectively allowing culture to become the dominant form of human adaptation. Once our brains reached this threshold, the biological drive for further, innate asterisk cognitive evolution largely ceded its role to the rapid advancements of learned knowledge and shared experience. It was the moment we became fully human, capable of abstract thought, planning, and collective memory on an unprecedented scale. But there's a curious inconsistency here. The speed and totality of this cognitive shift are baffling. It doesn't appear as a slow accumulation of subtle improvements, but rather as a profound, rapid change, an emergence of entirely new capabilities. Yet, since this initial burst, while we've built incredible civilizations, harnessed unimaginable technologies, and explored the cosmos, the asterisk fundamental cognitive architecture of the human brain seems to have remained astonishingly constant. Where is the evidence for continued asterisk biological asterisk enhancement of intelligence, of creativity, of abstract reasoning capacity? If evolution is a constant process, why this profound stasis in the very organ that defines our species, after such a dramatic and rapid initial expansion? The brain capacity, the neural pathways, the very hardware of our intellect, appears to have reached a plateau and settled there for tens of thousands of years. Could the Great Leap itself have been more than just an evolutionary step? Some theories suggest it was the activation of a profound genetic switch, unlocking dormant potential that had been slowly accumulating, but then also locking it into that precise, complex state. What if this wasn't just a natural progression, but the moment of delivery, where the final cognitive blueprint was instantiated, downloaded into the human genome? Perhaps having achieved a certain level of self-awareness and complex thought, the biological imperative for further, innate asterisk cognitive evolution simply ceased, having reached its programmed goal. Could our incredible achievements since then be less about ongoing biological improvement and more about the masterful deployment of a perfectly designed, finished cognitive product? This brings us to the most direct evidence of a possible evolutionary pause: the genetic signatures of stasis itself. Modern genetic studies, with their ability to sequence and compare ancient DNA with contemporary genomes, are beginning to reveal something deeply unsettling. In particular, they point to regions of remarkable stability and a surprising lack of expected variation over recent millennia, especially in gene regions associated with fundamental human traits, morphology, and cognitive function. This isn't just about small, random mutations. It's about a lack of significant, directional evolutionary pressure showing up in our genetic code. The mainstream scientific community acknowledges that human evolution has likely slowed down in terms of large-scale morphological changes. Gene flow, population bottlenecks, and new selective pressures have always shaped human populations, leading to small, continuous adaptations, often too subtle to observe without sophisticated genetic analysis. The focus has largely shifted to cultural evolution, arguing that our tools, societies, and technologies allow us to adapt to environments without needing to biologically change ourselves. We engineer our surroundings, rather than letting our surroundings engineer us. But the moment here is critical. Certain gene clusters, particularly those governing basic morphology and brain function, show a statistically anomalous lack of significant change compared to other species or earlier hominins over equivalent timescales. It's not just a slowdown, it's a profound holding pattern in key areas, almost as if these genes have been placed under a form of biological arrest. It's not a normal curve of variation. It's a distinct flattening, a plateau that defies typical evolutionary dynamics over such vast periods and across such diverse environments. The human genome in these critical zones seems eerily static. What could explain this unprecedented genetic stability in a species known for its adaptability? Some researchers entertain the idea that humanity simply reached an evolutionary optimum, where further genetic innovation provided diminishing returns, thus stabilizing the core genome. In this view, we became so perfectly suited to our niche that the pressure to change biologically was lifted. But this explanation feels incomplete. Environments are never truly stable, and human behavior constantly introduces new selective pressures. Or what if this stasis points to deliberate programming, a kind of genetic finalization that locked our species into a specific, predetermined configuration? Some researchers whisper of a biological governor, an unseen mechanism, a silent switch within our own code that activated and halted dramatic shifts once humanity reached a critical threshold of development. Could it be that our incredible capacity for culture and technology emerged not instead of biological evolution, but because a certain biological blueprint was made permanent? If our DNA, the very engine of evolution, shows signs of having settled into a strangely unchanging pattern, are we witnessing the natural end of a biological process, a species that has simply finished its design? Or are we confronted with the subtle signature of something far more profound? The concept of a species halting its fundamental evolutionary journey is unsettling, challenging our deeply ingrained understanding of life itself. It invites us to ponder the very fabric of our existence, the unspoken rules that might govern life's progression, and the possibility that our destiny was, in some fundamental way, frozen long ago. An enigma that speaks to a history far more intricate and perhaps far more controlled than we dare to imagine. This is not the end of our story. It is merely the beginning of the great question: why did we stop evolving? And what does that mean for who we truly are? The mystery we uncovered, the profound and sudden halt in our evolutionary journey, takes on an even more unsettling dimension when we descend into the very blueprint of our existence, our genes. For within the helical strands of human DNA lies perhaps the most compelling and most perplexing signature of this biological stasis. Genetic studies, comparing the ancient echoes within hominin DNA to the vibrant, complex tapestry of modern human genomes, reveal an anomaly, a startling deceleration in evolutionary change. Specifically, within gene regions once thought to be under immense, continuous pressure, crucial for human development and adaptation, we find an unexpected, almost eerie stillness. It is as if the relentless biological engine, which once sculpted our ancestors through millennia of constant refinement, suddenly quieted. The conventional understanding of recent human evolution posits a continuous, albeit subtle, adaptation. We are taught that our species, like all others, remains in a perpetual dance with its environment, constantly responding to new pressures. Dietary shifts, the advent of agriculture, migrations across continents, even the rise of complex cultures. All these, the mainstream view suggests, drive ongoing genetic modification, fine-tuning our biology through natural selection and genetic drift. Our genes in this narrative are always responsive, always subtly changing, an intricate feedback loop with the world around us. But there is a profound problem with this comforting explanation. When we scrutinize certain genetic hotspots, regions of our genome that dictate fundamental aspects of our humanity, we discover something unexpected. These critical areas show significantly less variation or change over recent millennia than would be statistically anticipated, far less than the vast timescales and persistent environmental challenges would dictate. The expected genetic flux, the ebb and flow of adaptation, seems to have entered a period of extraordinary, almost impossible calm. It's not merely a slowing down, it's an astonishing plateau, a locking into place. Some researchers, looking at this unexpected stability, have begun to consider interpretations beyond the conventional. Could humanity have reached an optimum biological state for its environment at a certain point, a pinnacle of design where further major changes were simply unnecessary? This theory suggests a kind of natural genetic equilibrium, a perfect balance achieved, perhaps, tens of thousands of years ago. Yet other, more unsettling theories emerge. What if this stillness points to the activation of a biological governor, or a genetic kill switch within our code? A mechanism that, once triggered, limited or entirely froze further significant morphological or cognitive evolution. It would be as if a master control program decided that the human form, at a certain juncture, was complete, requiring only minor updates, but no fundamental redesigns. Still others wonder if our environment, both natural and self-created through culture, became so profoundly stabilizing that it alleviated the need for radical biological shifts, effectively lowering the selective pressure for major genetic innovation. If our genes, particularly those defining our core biological essence, have largely settled into such a fixed pattern, what does this imply about our inherent biological plasticity, our potential for future adaptation in a world that is anything but static? What does this mean for the very definition of a living species, if its foundational blueprint has ceased its active, creative evolution? Let us delve into these specific genetic domains, for they whisper the most intriguing secrets. Consider the genes associated with brain development, size, and cognitive function. Genes like FOXP2, often linked to language, or ASPM and microcephalin, critical for brain size. These are the genetic architects of what makes us uniquely human. In our ancient hominin ancestors, these genes underwent periods of intense and rapid change, each mutation perhaps leading to a measurable increase in cognitive capacity or neural complexity. But when we examine their patterns of variation in modern humans, particularly over the last 50,000 to 100,000 years, something remarkable and profoundly quiet occurs. They exhibit an unexpected stability, a remarkable lack of significant, widespread mutations that would suggest ongoing, fundamental rewiring of our cognitive architecture. The furious pace of genetic innovation that built our sophisticated minds seems to have, quite simply, stopped. The mainstream perspective would argue that the rapid evolution of the human brain reached an optimal configuration for our species. Further changes, while perhaps occurring, are deemed subtle, driven more by cultural learning and epigenetics than by gross morphological or neuroanatomical redesign through new genetic mutations. It's argued that our brains are still evolving, but in ways that are harder to detect, operating on a level of nuance rather than radical restructuring. But here is the core of the paradox. The sheer lack of significant, impactful mutations or beneficial alleles widely adopted across populations in these fundamental brain development genes in the post-Upper Paleolithic period is statistically improbable, especially when considering the massive environmental shifts, population expansions, and cultural explosions that follow. If evolution were truly continuous and adaptive at the same pace as in earlier hominins, we should see more evidence of large-scale genetic experimentation and successful new designs for our neural pathways. Instead, what we observe is a genetic plateau, a fixed point from which deviations are minor, and the foundational framework remains untouched. It's as if the fundamental architectural drawings for our minds were completed and then filed away, marked final. Could it be that we simply hit a biological ceiling for brain size or efficiency that the human body could physically and energetically support? Or, more speculatively, was this genetic stability a deliberate outcome? Did the hypothesized switch specifically target the genetic pathways for neural plasticity and development, locking in a particular cognitive architecture that was deemed complete? Some theories even venture into the idea that a perfect cognitive blueprint was delivered or achieved at this juncture, rendering further major biological redesigns unnecessary or even detrimental. The potential for the brain to evolve further to transcend its current form may have been quietly, irrevocably capped. Has our mind's biological framework been subtly, imperceptibly frozen in time? Are our cognitive abilities, which we often view as endlessly adaptable, tied to a genetic configuration optimized for a world that ceased to exist tens of thousands of years ago? Or has the very potential for fundamental biological cognitive advancement been subtly, permanently switched off? Next, we turn our gaze to the more tangible framework of our existence, our skeletal structure and morphology. The archaeological record, stretching back tens of thousands of years, reveals a striking phenomenon. The skeletal remains of anatomically modern humans from the Upper Paleolithic period bear an astonishing resemblance to our own. While minor variations exist, differences in robustness, subtle shifts in jaw size, or slight changes in average stature, the overall anatomical blueprint, the fundamental design of our bones and proportions, is remarkably consistent. Cranial capacity, limb proportions, dental structure, these core features, which underwent radical and rapid transformations in earlier hominid lineages, appear to have entered a phase of profound stasis. The extensive and often dramatic shifts seen in our ancestors seem to have quieted, giving way to a period of remarkable morphological stability. Mainstream science acknowledges this stability, often framing it as the result of anatomically modern humans having achieved a highly successful and adaptable form. Subsequent changes, it is argued, are minor, microevolutionary adaptations. Reductions in jaw size are attributed to changes in diet and food processing, e.g., cooking, variations in bone density to shifts in lifestyle and activity levels, and subtle differences in body proportions to adaptations to local climates. These are seen as ongoing, subtle adjustments within an already established, successful template. But the rate of these morphological changes, even the subtle ones, has dramatically slowed. We no longer observe the kind of significant directional selection for novel skeletal forms, or the robust physiological adaptations that characterize the vast sweeps of earlier human evolution. Where are the new bone structures, the radically altered limb proportions, the entirely new physiological features that would denote continuous, large-scale biological experimentation? Instead, the changes we observe are more akin to minor edits within an unshakable master document. The blueprint seems largely finalized, lacking the widespread, inventive modifications seen in many other rapidly evolving species. The variations are contained within a narrow, predetermined range, suggesting an enduring, almost static type, rather than an open-ended process of fundamental recreation. Could our physical form, the very architecture of our bodies, have reached a peak of efficiency and adaptability for a wide range of terrestrial environments, thus negating the need for further radical changes? Or is there a more profound explanation? What if the genetic governor that we've discussed extends beyond the brain, regulating the entire somatic blueprint, ensuring a remarkable and enduring consistency in our physical appearance across millennia? Some might even speculate that this specific anatomical configuration was deemed complete or ideal by whatever unknown force or event initiated the switch, freezing us in a form that was, for reasons we do not yet comprehend, considered perfect. Has our physical form, meticulously designed and refined for an ancient past, inadvertently become a biological constraint? Does this enduring blueprint limit our inherent ability to truly adapt to the unprecedented physical challenges of the future? Or does it, paradoxically, represent an enduring, perfected design that has simply achieved its optimal state? Even in the most dynamic battleground of the human body, our immune system, we find curious patterns of stasis. These are the genes under immense and constant selective pressure, tirelessly adapting to an ever-evolving parade of pathogens. Yet within certain core elements of our immune response, we discover unexpected stability, or highly localized, rather than systemic, change over recent millennia. Genes related to fundamental immunity, broad disease resistance, and susceptibility show less broad innovation, less radical redesign than one might expect from a species locked in a ceaseless co-evolutionary arms race with countless microorganisms. It's a subtle but persistent undercurrent of genetic conservatism. Mainstream science firmly asserts that the human immune system is a vibrant, continuously evolving entity. It must be, to keep pace with new viruses, bacteria, and parasites. We see clear evidence of this ongoing adaptation. The widespread prevalence of genes for lactose tolerance in populations with a history of dairy farming, or specific alleles conferring resistance to malaria in regions where the disease is endemic. These are textbook examples of natural selection at work, demonstrating the ongoing adaptive capacity of our species. But beneath these localized adaptations, a deeper pattern emerges. While individual immune system genes might fine-tune their responses to specific, regional threats, the core architectural genes, the fundamental framework of our defense mechanisms, show a remarkable resilience to radical restructuring. We observe fine-tuning, yes, but not revolutionary redesign. The overall strategy, the fundamental biological infrastructure of our immune response, seems to have been set, then merely iterated upon, rather than fundamentally re-engineered. It is as if the genetic innovation in key, foundational areas of our immune system has plateaued, leaving us with a consistent, yet not universally adaptive, immune blueprint. The radical shift seen in the immune systems of other rapidly evolving mammals seem conspicuously absent from our own recent history. What could account for such a peculiar equilibrium in such a vital and dynamic system? Could it be that the human immune system, at some point, reached an optimal balance with its typical pathogen load, and any radical changes would be disruptive, even detrimental? Perhaps the genetic governor, if it exists, also calibrates the immune system, allowing for minor adjustments in response to immediate threats, but preventing major structural overhauls that might compromise the overall stability and integrity of the entire biological system. Or more controversially, could the blueprint for humanity have been designed with a specific level of pathogen interaction in mind, and our immune response capacity, while robust, was subtly capped at a predetermined level? This would imply an ancient equilibrium subtly enforced within our genetic code, defining the boundaries of our defense. If our immune system's core design has been relatively static for millennia, does this imply that we are biologically predisposed to certain disease vulnerabilities, an enduring legacy from an ancient past? Or has an ancient equilibrium, a profound and subtle balance, been silently, irrevocably enforced within our genetic code, determining the very limits of our biological defense? Stepping back from individual genes and looking at the human genome as a holistic entity, we begin to perceive a pervasive hum of stability. Beyond the specifics, there is a background rate of change that, while certainly present, distinctly lacks the dramatic, systemic shifts observed in earlier epochs of hominin evolution, or for that matter, in many other rapidly evolving species. This overall genomic signature, a subtle yet persistent undercurrent, hints at a broader cessation of major adaptive restructuring, a profound shift from active evolution to a state of genomic preservation. The symphony of change that once defined our lineage seems to have resolved into a long, sustained chord. The mainstream scientific consensus emphasizes the human genome as a dynamic entity, a sprawling landscape of constant mutation, recombination, and selection. While it's acknowledged that obvious morphological changes are rare in modern humans, the belief is that subtle biochemical and physiological adaptations continue unabated, driving evolution at a micro level. The sheer complexity of the human organism, it is argued, means large-scale changes are less likely, but microevolutionary processes are pervasive and ever-present, ensuring continuous, if imperceptible, adaptation. But the data, when viewed through a different lens, tells a more nuanced story. Statistical analyses, incorporating genome-wide association studies and the increasingly rich trove of ancient DNA, reveal what appears to be a distinctive bottleneck or plateau in the rate of asterisk beneficial or asterisk directed adaptive evolution across a wide array of functional gene categories. It is not just a general slowing down. It is more akin to an asterisk locking in of a specific genomic configuration. The widespread genetic experimentation that defined earlier hominin evolution seems to have ceased, or at least dramatically diminished, giving way to a new paradigm of preservation over innovation. The very architecture of our genetic code, in its most fundamental aspects, appears to have settled. What could instigate such a profound and sweeping genomic stasis? Some theorize that humanity simply achieved a kind of universal genetic fitness, a broad adaptiveness that negated the need for further radical biological modification across diverse environments. Our ancestors, perhaps, developed a genome that was good enough for most challenges, leading to a general deceleration of intense selective pressures. Yet, more intriguing possibilities emerge. Could the kill switch, or genetic governor we've discussed, be not localized but truly global, affecting the entire genome's capacity for major evolutionary leaps? This would imply a systemic mechanism, a master control that enforced a state of biological conservation. Or, daringly, what if our genome was, from a certain point, designed asterisk to operate within specific parameters, and these parameters were finally locked down, turning us into a highly stable, albeit perhaps less mutable, species, a biological artifact of a specific, perhaps externally determined optimal state? Is this profound, overall genomic stasis a silent testament to a perfected biological design, an enduring pinnacle of form and function that simply required no further major changes? Or is it, instead, a testament to an imposed limitation, a subtle yet profound cage that has defined our biological fate, a quiet harbinger of a biological reality we have yet to fully comprehend. The genes, it seems, have secrets yet to yield, and their profound stillness only deepens the mystery of why we stopped evolving. Following the genetic signatures of stasis we've uncovered, the next logical, and perhaps most unsettling, question emerges. When exactly did this evolutionary pause take hold? When did the hypothetical genetic switch, if it exists, truly flip, locking humanity into its current form? The archaeological and anthropological record offers a curious, almost paradoxical, timeline for this deceleration. If we look closely at the Upper Paleolithic period, roughly 50,000 to 10,000 years ago, we encounter what is often termed the Great Leap Forward. This era is characterized by an explosion of human creativity, innovation, and complex behaviors. Suddenly, it seems, our ancestors began crafting sophisticated tools, not merely crude flakes, but finely worked blades, spear throwers, and intricate bone needles. They adorned themselves with jewelry, created breathtaking cave art depicting animals and symbols in places like Lascaux and Chauvet, and developed intricate burial rituals suggesting abstract thought and an understanding of the afterlife. Evidence points to the rapid emergence of symbolic language, complex social structures, and an unprecedented mastery over their environment. This period is seen as the genesis of truly modern human behavior, a point where our intellectual and cultural capabilities soared. Yet it is precisely within this time frame of immense cultural dynamism, or perhaps shortly thereafter, that the genetic markers we examined earlier suggest our physical evolution, our biological adaptation, began to stabilize, to slow dramatically, eventually reaching a quiet stasis. Mainstream scientific thought generally interprets this great leap forward, the subsequent advent of agriculture, and the shifts brought about by climate change, as profound drivers of human evolution. The cognitive revolution of the Upper Paleolithic, for instance, is seen as leading to the development of complex language and abstract thought, which in turn allowed for unprecedented cultural adaptation. When our ancestors faced new environmental pressures or dietary challenges, instead of evolving longer limbs or thicker fur, they developed technologies like clothing, shelter, or farming techniques. The rise of agriculture, beginning around 10,000 years ago, is often cited as a prime example of redirected evolution. Rather than our bodies biologically adapting to new food sources or sedentary lifestyles, we adapted our environment to suit our existing biological needs. We cultivated crops, domesticated animals, and built permanent settlements. This perspective suggests that, while physical changes became less pronounced, human evolution continued unabated, simply shifting its primary mode from biological to cultural adaptation. Our advanced intelligence and capacity for innovation essentially rendered rapid biological evolution superfluous, allowing our physical form to reach a kind of optimal state from which culture could flourish, continuously adapting to the world around us. This narrative offers a comforting explanation. We simply outgrew the need for constant genetic modification, our minds becoming the primary agents of change. But what if this widely accepted narrative, this comfortable explanation of cultural adaptation taking precedence, is merely observing a symptom, not the cause? What if the Great Leap Forward and the agricultural revolution are not evidence of ongoing biological evolution, but rather the consequence of our biology having already been locked into an optimal, stable state? The profound genetic stability we've observed, the silent cessation of significant biological change, might have been the very foundation upon which these monumental cultural shifts were built. Imagine a scenario where our species reached a specific biological equilibrium, a perfectly tuned body and brain, And it was this stability that then unleashed an unprecedented capacity for innovation, symbolic thought, and complex social organization. The biological stasis in this view wouldn't be an incidental outcome of cultural progression, but rather its essential prerequisite. Could the switch have predated these cultural revolutions, perhaps enabling them by providing a robust, efficient, and unvarying biological platform from which to launch such advancements? It's as if a highly sophisticated machine reached its final, perfected design, and only then could its true, advanced functionalities be fully exploited. The biological locking mechanism might not have merely coincided with these revolutions. It might have been the silent, unseen hand that allowed them to flourish. By providing an unchanging, stable biological canvas upon which the vibrant tapestry of human culture could be woven. This pivot in perspective opens the door to a series of more speculative, yet deeply intriguing, alternative theories regarding the trigger for this primordial switch. Could it have been a unique environmental confluence? A prolonged, perhaps unprecedented, period of planetary stability? A golden age, where selective pressures were significantly reduced, allowing our genome to settle into a state of equilibrium? Perhaps a prolonged interglacial period, or a specific cosmic alignment, bathed Earth in energies that subtly encouraged genetic stabilization, rather than mutation and change. This would suggest a kind of natural, external tuning that inadvertently locked humanity into a particular biological form, perfectly adapted to a fleeting moment of planetary calm. Moving into more profound speculation, some researchers consider the possibility of a self-imposed genetic modification by an ancient, highly advanced precursor civilization. If humanity, in a previous cycle of advancement now lost to history, reached an unparalleled understanding of genetics and its own biology, could they have deliberately optimized and then locked down their own genetic code, perhaps to preserve an ideal form, to prevent undesirable mutations, or to achieve a kind of biological immortality within their lineage? And if such a civilization exists, then there is the concept of a planetary energy shift. What if a grand cosmic event, a profound, yet subtle, change in Earth's geomagnetic field, or the influence of an unknown stellar energy signature, acted directly upon the very fabric of life? Could a resonant frequency, emanating from deep space or from within the Earth itself, have subtly altered the stability of DNA replication, gene expression, or the mutation rates across an entire species? This theory posits a powerful, unseen force, a kind of biological frequency tuner that brought about a species-wide genetic recalibration, locking it into a new, stable state. Such an event would be beyond our current understanding, suggesting a profound interplay between cosmic forces and biological evolution that mainstream science is only beginning to explore. Perhaps the most unsettling of these alternative theories points to a pre-programmed biological mechanism. What if, embedded deep within our genetic code, there exists a self-regulating sequence, a kind of biological timer? This mechanism, upon humanity reaching a specific developmental milestone, either biologically or perhaps even cognitively, or in response to a predefined environmental condition, could have activated a lockdown command, a failsafe, or a deliberate design feature to prevent uncontrolled deviation from a template. This switch might not be unique to humanity. It could be inherent to all sapient species across the cosmos, a universal law of biological development that dictates a point of completion to allow for cognitive and cultural, rather than morphological, evolution. In this view, our biological stasis isn't an accident or an intervention, but an inherent, preordained step in the grand cosmic unfolding of intelligent life, a necessary state for a species to transcend mere biological adaptation and embark on the boundless journey of cultural and intellectual exploration. The implications of pinpointing such a primordial switch are profound. Was this switch an accidental evolutionary cul-de-sac, a random genetic event that inadvertently locked our species into its current form, irrevocably altering our trajectory? Or was it a deliberate design for a specific, yet unknown, purpose, guiding humanity down a predetermined path towards some ultimate objective? Or, perhaps most philosophically, was it an inevitable outcome of reaching a certain, what one might call an ideal, biological threshold, a peak of efficiency and stability, beyond which further morphological evolution becomes either unnecessary or even detrimental to the species' overall potential? The timing of this proposed genetic pause, nestled as it is between our earliest origins and our present, forces us to re-examine not just what we are, but why we are this way, and what forces, seen and unseen, truly shaped our enduring, unchanging form. The great leap forward, far from signaling continuous evolution, might instead be the most powerful piece of archaeological evidence for a profound biological halt, the consequence of a genetic locking mechanism that redirected our destiny, forever freezing the biological essence of humanity. Having explored the nature of this profound genetic stasis, and the mechanisms that might have brought about such an abrupt halt to our biological evolution, we are drawn now to consider its deeper implications. What does it truly mean to be a species frozen in time, biologically speaking? What adaptive pathways might have been forever closed off to us when the switch was pulled? And what silent legacy does this leave for our long-term survival in an ever-changing world? The very idea of humanity existing as a fixed biological entity, rather than a continually adapting one, conjures an image both serene and unsettling. A perfectly sculpted statue, perhaps, but one no longer capable of molding itself to new pressures. The mainstream scientific narrative acknowledges that human evolution, while not entirely stagnant, has indeed slowed considerably in recent millennia, especially compared to the rapid pace observed in our deep ancestral past. This conventional understanding posits that humanity has simply grown too clever for its own good, in an evolutionary sense. Our advanced cultural and technological evolution, it is argued, has largely supplanted the need for rapid biological change. We don't grow thicker fur. We invent clothing and central heating. We don't develop stronger jaws. We cook our food and craft sophisticated tools. In this view, our ingenious capacity to modify our environment and invent solutions to challenges means that selective pressures for biological evolution have significantly diminished. We have, in essence, created our own ecological niche, where cultural adaptation becomes the primary mode of survival, making continuous biological flux less critical for our species' persistence. But this perspective, while compelling in its elegance, overlooks a deeper, more disquieting possibility. If the genetic stasis we have discussed is not merely a consequence of relaxed selective pressures, but rather the result of a more fundamental, perhaps even deliberate biological lockdown, a true genetic switch, then the implications are far more profound. This isn't just a slowing down, it's a cessation, a fundamental limit. Can cultural evolution truly compensate for a biological stasis if that stasis signifies a lack of inherent biological adaptability that our ancestors demonstrably possessed? It is one thing to adapt culturally, building new tools or systems. It is another entirely to possess the intrinsic, genetic plasticity to spontaneously develop new biological traits in response to unforeseen environmental catastrophes or novel pathogens. A reliance solely on cultural solutions, however advanced, might inadvertently leave us vulnerable in ways that a continuously evolving species might avoid. The but moment arises from the uncomfortable question of whether our advanced civilization is a shield or a cage, perfectly designed to maintain the status quo, but perhaps inherently limited in its capacity for truly novel biological responses. The alternative theories begin to paint a more complex, and perhaps more haunting, picture. One perspective suggests that the activation of this genetic switch, if it occurred, may have been a mechanism to preserve an optimal biological state. Perhaps, at a certain point in our ancient history, humanity reached a peak of physiological and cognitive perfection, perfectly adapted to its then current environment. The switch could have been a biological safeguard, locking in this ideal blueprint, ensuring that this successful design was maintained. In this view, modern humans are, in a sense, living fossils of their own peak, a species so exquisitely crafted for a specific past environment that its genetic program was deemed complete, no longer requiring major modification. We carry within us the echoes of a perfected past, a stable form that once represented the zenith of adaptation. Consider a creature like the coelacanth, a fish thought extinct for millions of years, found alive and virtually unchanged. It represents a form so successful in its deep-sea niche that it ceased to evolve. Are we, in a more complex terrestrial sense, a similar phenomenon, but one whose ideal environment has long since vanished? Conversely, and perhaps more disturbingly, the genetic lockdown could represent not a preservation of perfection, but a loss of crucial genetic variability. Evolution thrives on variation, the raw material for natural selection. If the switch diminished this genetic plasticity, if it narrowed the range of possible biological responses, then it could leave us inherently less robust, less able to generate the spontaneous adaptations needed for future challenges. Imagine a species continuously evolving, its genetic code a vibrant tapestry of constant modification and experimentation. Take, for instance, certain bacteria or viruses, which evolve at breathtaking speeds, constantly adapting to new environments or developing resistance to antibiotics. While their short lifespans contribute to this, their genetic mechanisms allow for profound and rapid change. Compared to this dynamic biological fluidity, humanity's genetic landscape, as we've discussed, appears remarkably static. We might be excellent at inventing new medicines, but if our fundamental biological systems are less adaptable, then a truly novel pathogen or an utterly transformed climate could pose a threat far greater than we currently perceive. This concept aligns with what some biologists call evolutionary traps, where a highly successful adaptation in one era becomes a constraint in another. A species might become so specialized, so perfectly suited to a narrow set of conditions, that any significant change in those conditions renders its perfection a fatal flaw. For example, the saber-toothed cat, Smilodon asterisk, with its massive fangs, was superbly adapted to hunting large, slow prey. When those prey species declined, Smilodon asterisk's specialized tools became a burden, leading to its extinction. Could our seemingly perfect, ancient form locked in place be setting us up for a similar, though perhaps slower, kind of trap? Our ancestors, constantly adapting, possessed a biological fluidity that allowed them to navigate dramatic climatic shifts and diverse ecosystems. We, in our modern form, appear to have shed this inherent adaptability for the stability of a fixed genetic template. This notion extends beyond mere physical traits. What if the genetic switch also impacted our cognitive evolution? Subtle changes in brain structure or function that would have otherwise emerged. While our intelligence is undeniably profound and has allowed us to build civilizations, what undiscovered forms of perception, thought, or even consciousness might have been available to a species whose biological growth was truly unconstrained? The possibility arises that by locking in an optimal physical form, we simultaneously locked in a specific cognitive architecture, one that, while incredibly capable, might still be a fraction of what our species could have become. We excel at logic and pattern recognition, but perhaps other forms of intuition or sensory processing, less relevant to our ancestral environment, were trimmed from the genetic blueprint. The profound stillness within our genome forces us to confront the question of purpose. Was the switch, a necessary stabilization for the emergence of complex consciousness and culture, a trade-off where biological flux was exchanged for cognitive steadfastness? Or was it an arbitrary, perhaps accidental, curtailment of our species' ultimate biological potential, leaving us permanently tethered to an ancestral form that might not serve our distant future? We are a species that dreams of conquering distant stars, of terraforming new worlds, yet our fundamental biological hardware remains calibrated for the African savanna of tens of thousands of years ago. Our bodies struggle with new diets, new pollutants, new sedentary lifestyles, showing resistance to change at a very deep genetic level. The modern epidemics of chronic diseases could be seen not just as failures of lifestyle, but as evidence of a biological system struggling to adapt to conditions far removed from its genetically inscribed default. The comparison with other species, continuously responding to selective pressures, throws our own predicament into stark relief. While a dolphin's body shape remains relatively stable, its genetic programming allows for subtle, ongoing adaptations to ocean chemistry, food availability, and predator pressures. Even within human populations, historical adaptations exist, like lactose tolerance or resistance to certain diseases. But these are often single-gene shifts, microadaptations, not the broad, foundational morphological and neurological changes that characterize deep evolutionary journeys. It is as if the engine of broad, macroevolutionary change within our species has been put into neutral, while only minor systems are allowed to tinker. So, are we, as a species, living with the silent legacy of a perfected past, enjoying the enduring stability of a biological form that once represented an apex, a zenith of evolutionary design for a particular moment in time? Or, conversely, are we unknowingly carrying the burden of a profound biological limitation, unable to truly adapt at a fundamental, cellular level to the unprecedented challenges we face in an accelerating future? The answer remains elusive, a silent whisper in our very DNA, leaving us to wonder if our evolutionary journey reached a destination, or simply encountered an unexpected, and perhaps irreversible, roadblock. We have charted the astonishing stasis of our own genetic code, explored the moments when the evolutionary switch might have been thrown, and pondered the profound implications of living with a biological inheritance from a perfected past. But what if the deepest mystery of our unevolving form lies not in the mechanics of biology, but in the realm of purpose? What if the why behind humanity's evolutionary freeze transcends the merely physiological, pointing instead to a deeper, more unsettling truth about our origins and our place in the cosmic narrative? This anomaly, this great stagnation of our biological selves, compels us to look beyond random chance, to consider whether there was an unseen architect. For much of modern science, the answer to such profound questions remains tethered to the tangible, the observable, the empirically verifiable. The scientific community, by its very nature, maintains a rigorous reticence to attribute phenomena, however perplexing, to anything beyond natural, explainable, even if currently unknown, biological and environmental processes. They would argue that the apparent cessation of our major evolutionary shifts is simply a testament to our remarkable cultural adaptability. As civilizations blossomed and technology advanced, our environment became increasingly self-engineered. We built shelters, developed agriculture, cured diseases, and clothed ourselves, effectively removing many of the traditional selective pressures that once drove rapid biological change. In this view, our genes simply reached an optimal configuration for our evolving niche, and our minds, rather than our bodies, became the primary arena of adaptation. The long, slow grinding of natural selection, they might contend, simply found a stable equilibrium. Humanity, in this framework, continued to evolve, but it did so through ingenuity and culture, rather than the slow, arduous path of genetic mutation and physical transformation. The genetic studies that show reduced variation, they would suggest, are merely snapshots of a species that has achieved a unique form of environmental mastery, where the demands for physical alteration have been largely mitigated. The switch, if one were to even entertain such a concept, was simply the subtle hand of an increasingly complex culture, gently nudging us away from the primordial pressures that once sculpted every living thing. But the sheer suddenness of this evolutionary freeze, its completeness across critical biological systems, and the curious synchronicity of its timing with the so-called Great Leap Forward, that explosive blossoming of human creativity and complex thought, demands a radical reevaluation. It stretches the boundaries of what constitutes a natural, evolutionary event. If cultural evolution simply replaced biological evolution, why such a distinct halt in the biological asterisk record? Why not a slower, more gradual deceleration, with lingering subtle changes still detectable? The genetic data, as we've explored, suggests not a fading evolutionary path, but a road that abruptly ends, a biological blueprint that was suddenly and decisively finalized. This isn't merely adaptation. It feels like a cessation, a locking into place. The evidence doesn't speak of a species slowly winding down its physical modifications, but one that reached a point of absolute, profound stasis. This is a crucial distinction. It prompts us to ask whether our origins are not simply a product of random mutations and environmental pressures, but something far more deliberate, far more purposeful. Could it be that humanity, at a certain point in its development, became the focus of an intervention? Some researchers, looking at this profound biological stagnation, have dared to consider the possibility of an influence from an advanced, non-human intelligence. Perhaps these unseen architects, observing our nascent species, deemed our biological development satisfactory at a particular juncture. Imagine a cosmic gardener, carefully tending to a promising seedling. At a certain point, finding the plant perfectly formed for its intended purpose, the gardener might apply a stabilizer, ensuring no further uncontrolled growth or mutation. What if our genetic freeze was such a moment? A deliberate act to preserve a specific iteration of humanity, an optimal biological state, for reasons unknown to us. These entities might have possessed the advanced genetic technology to enact such a profound alteration, to subtly, yet definitively, install a biological governor, ensuring that our physical form, the vessel for our consciousness, would remain constant while our minds and cultures were left free to explore their full potential. This would imply a vast, overarching plan, a deliberate shaping of destiny. Our physical constancy, then, would not be a limitation, but a foundational platform for higher development, a controlled variable in a grand, cosmic experiment. The implications ripple across our understanding of intelligence and its forms. Such a hypothesis suggests that these non-human intelligences might not value endless biological change, but rather a perfected, stable form that acts as a consistent interface for consciousness. Our current bodies, therefore, might not be an unfinished work of nature, but a finished product of design, a living monument to a blueprint delivered, rather than discovered. This line of thought suggests that the great stagnation is not a mark of deficiency, but of distinction, an indicator that we passed some cosmic test, earning a permanent place in an unseen gallery of perfected forms. What if this intervention was not about control, but about stewardship, about guiding a promising species towards a specific, higher purpose, protecting it from the unpredictable vagaries of further, potentially destabilizing biological evolution? The idea is as profound as it is unsettling, hinting at a universe far more managed and deliberate than our current scientific paradigms allow. Alternatively, the unseen architect might not have come from the stars, but from our own forgotten past. What if an ancient, advanced civilization, one that flourished on Earth millennia ago, reached a similar evolutionary crossroads and, through their own mastery of genetics, engineered their own biological stability. These precursor civilizations, perhaps having witnessed the perils of unchecked biological drift, or having achieved what they deemed to be the ultimate human form, might have sought to preserve it, not just for themselves, but for their descendants, for the future inhabitants of this planet. Could their legacy have been a subtle, yet powerful, genetic software update, woven into the very fabric of the evolving human genome? Perhaps they left behind a genetic sentinel, a self-activating mechanism that would trigger upon humanity reaching a certain level of cognitive development or environmental saturation, gently, irrevocably, locking our genes into a predetermined pattern. This would make us, in a sense, a living inheritance, a continuous echo of their perfected form. Their motivations could have been complex, a desire for continuity, a subtle guidance for future generations, or even a desperate attempt to avoid some perceived evolutionary pitfall they themselves encountered. Such a theory connects the ancient mysteries of our planet with the deepest secrets of our biology, suggesting a lineage far more sophisticated and intentional than a mere chain of ape-like ancestors. If such a civilization existed, their knowledge of biology, physics, and the very fabric of reality must have been immense. They could have understood the delicate balance between biological change and cultural stability, perhaps concluding that infinite physical variation was ultimately detrimental to long-term societal progress. Their intervention might then have been an act of profound foresight, a gift of genetic stability bestowed upon their distant descendants. We, therefore, might be living beneficiaries of an ancient, compassionate design, inheriting a form that was deemed perfect not by random chance, but by a wisdom lost to time. The great stagnation in this light transforms from a biological anomaly into a grand, silent testament to a forgotten age, a subtle manipulation from the dawn of human consciousness that set us on a predefined path. Our very stability could be the most enduring and most overlooked artifact of a lost empire. Yet another, perhaps even more profound, possibility exists, a universal law of biological development for sapient species. What if the evolutionary freeze isn't unique to humanity, nor the result of specific intervention, but a common endpoint for all intelligent life across the cosmos? Could there be a cosmic programming, a subtle, underlying principle that dictates a point of completion for species once they reach a certain threshold of consciousness, self-awareness, and technological capability? This universal law might suggest that once a species develops the capacity for complex thought, for abstract reasoning, for cultural transmission and the creation of tools and language, the engine of rapid biological evolution inherently slows, then stops. Its purpose shifts. The energy and resources previously dedicated to physical adaptation are redirected, becoming the fuel for cognitive and cultural evolution instead. In this framework, our physical bodies become stable platforms, vessels perfectly adequate for the exploration of consciousness and the building of civilizations, while the true evolution continues in the realm of ideas, art, philosophy, and technology. This would imply that the great stagnation is not an anomaly, but an inevitability, a predictable stage in the cosmic development of intelligent life. It is the moment when a species sheds its primordial need for constant physical reshaping and steps onto a new path, one where the universe is explored not through the slow, blind march of genetic mutation, but through the deliberate, conscious expansion of knowledge and understanding. Humanity, in this vast cosmic tapestry, would simply be following a predetermined script, arriving at a universal threshold where biology yields to sentience. The genetic switch, then, would be a universal clock, ticking down to a pre-programmed activation once certain criteria of consciousness are met. This perspective offers a strangely comforting, yet equally unsettling, vision of our place in the universe. We are not alone in our unique evolutionary path. We are simply part of a grander, universal design. Whether the whisper of an external intelligence, the echoes of a lost terrestrial civilization, or the grand design of a universal law, the core question remains. What does this tell us about our own identity? The idea that humanity might not be an unfinished work, but a deliberate, completed project, forces us to confront a profound truth. We may be a finished biological product in a cosmic timeline, a masterpiece deemed complete, rather than a species constantly striving for further physical refinement. This isn't a summary of our journey, but a final, lingering thought, a profound insight that compels us to reconsider everything. Is our current form, then, a pinnacle of design, a perfect vessel for consciousness in this moment of the universe's